I'm on the line with Jeffrey Dowling, who is our presenter for the day. He is our science curriculum specialist here at Key Curriculum Press. So Jeffrey is on as well. And
hi there, everybody. Welcome to our LBC webinar.
And Jeffrey, I'm thinking, and another thing we're checking is voice. So if we are talking too soft, too loud, please let us know and we'll do some adjustments as well. Jeffrey,
yeah, I'm using a new microphone.
Yeah, from my perspective, you're kind of loud, so maybe
kind of loud, okay.
Kind of loud. So I know that I have that problem. I have that teacher voice, so I tend to have the microphone way far away from my mouth.
You know what it is that my last microphone didn't work so well, so I got used to talking really loud.
Okay, well,
so it's working
well this time, at least what I can hear. So if anyone wants to send us a comment if you can't hear, actually if you can't hear, how can you send us a comment? So I am going to send a written message, which you should all see appear in your control panel in the question part, to anyone who may not be able to hear us currently. So I'm turning it over to Jeffrey to kill the empty space while I'm typing here.
Yes, Sharon Harris says that we both sound fine, so that's good.
Oh, good. Thanks, Sharon.
And everybody should be seeing a slideshow that kind of advances on its own that talks a little bit about you know, what your control panel looks like right now. It's letting you know that everybody who's out in the audience will be on mute. So if you want to communicate with us, use the question panel. And then there's just some features of Living by Chemistry that you'll be seeing, and we'll be getting started in, I think, just a minute.
Like 2 minutes, according to my little official clock here. We've got we've got less than half the folks that are supposedly registered, so we'll give some people more time to log on. Hopefully we'll get some more folks on. Just a couple things as we're sitting here waiting. We do record all of our webinars, and so this one is being recorded, and we post them on our website for on-demand viewing anytime you want. So that's available at keypress.com/webinars, and you should see the listing of all of our webinars. We have the chemistry ones, but we also have our Sketchpad webinars and our Discovering Mathematics series webinars. So if you click that link or go to that link, you can see all the upcoming webinars and as the previously recorded webinars. And we've been doing this since I think about May, though we did just start the chemistry one. So we have quite a few webinars there to look at if you're interested in that. In just a minute, again, I'm looking at a minute that we're going to get started. We want to value your time and start on time. Couple things about the webinar. We do keep everyone on mute during the webinar because of all the background noises and the feedback that happens. So you will stay on mute the entire time. So the best way to communicate is to type questions, comments in the question panel, which is on the right-hand side of your screen. And periodically I might send a message, or if Jeffrey asks a question, he may ask you to respond using that question panel. So make sure you can find it. There's a picture of it currently on the screen right there. And you simply type in your question and we will respond. I'm online to answer questions during the webinar if I can. I am a math person, so science questions might throw me for a loop there. But I will do my best, or I will read them out loud to Jeffrey. All right, Jeffrey, it looks like it's about time to get started, so I am going to pass things on over to you.
All right, I'm going to load up our actual slideshow. And so just quickly, my picture's a little grainy, but you're here again with Jeffrey Dowling and Karen Greenhouse. We're here at Key Press. This information for our email addresses and whatnot will be showing at the end if you needed to contact us to get any information. I also did, for those of you that were signed up before yesterday afternoon, I did post a worksheet that students might use with the particular lesson we're going to be covering today, and I sent an email about that. So if you did not get that, feel free to jot down this email address and send me a message. I can get that to you. You don't actually need the worksheet to participate in today's webinar, but I wanted to give you the perspective that students would have if they were doing this lesson in class. So I think we should just jump right into it.
I think so. Let's do it.
I think I'll do that. And you know what? Before I do that, I do have some poll questions. These two questions are kind of to get you used to the system of polling that we do. So let me launch a poll. And I know we asked you these questions when you were signing up for the webinar, but just so that everyone can get a sense of who's here, can you you choose all that apply here in terms of what types of chemistry courses you're teaching, and in a moment I can close that and give everybody a chance to see who's here. And so it looks like everyone's had a chance to do that, and it looks like the poll feature is pretty self-explanatory, so that's good. Let me close that. And as of right now, it looks like we've got quite a few teachers here that are teaching a first-year general chemistry course, some teachers teaching what might be considered an intro to chemistry or conceptual course, about 44% teaching an honors chemistry course, and we have 22% saying other. Can some of you who are teaching other courses use the question panel to let us know what you might be teaching, if you would like to?
And Jeffrey, don't forget to close the poll.
Thank you.
There you
Because
go.
I did forget. All right. So if anybody wanted to share with that, you can use the question panel. I'm going to move on to the next question. For those of you who are familiar with our program, we welcome you back, and I wanted to find out, is anyone currently using Living by Chemistry in your classroom? So if you're currently using our first edition materials, which include our brand new student textbook, let us know. Or perhaps you know us because of our preliminary edition that we had out for about 5 years before the first edition. And then some people might have supplemented their current curriculum with lessons that they maybe downloaded from the website or picked up at a workshop, and we're excited that you're trying it out. And then for those of you that aren't, let's just take a look, and that just helps me to know what level of explanation to give on certain items. So I'm going to close that out and share that. And
Wow.
it looks like a few people are using lessons, that they're supplementing the curriculum, so that's great, and many of you have not used this before. So we're hoping that if if you have any questions about the curriculum, please use the question panel as we go along, as we kind of talk to you about it. So I'm gonna hide that poll and jump back in. And just a minute. For those of you who've not heard of Living by Chemistry at all, what is Living by Chemistry? Well, it's a standards-based high school chemistry program where we provide you the support that you need to teach inquiry-based lessons each day of the year. So this is a guided inquiry program, and what you're seeing up there is actually a picture of the student textbook. But what you see here now is an image of the student textbook and the 6 teacher resources that we provide for you. So those teacher guides on the right give you all the information that you would need to teach guided inquiry lessons every day. And as you can see, the curriculum is broken up into 6 major themes. We start off the year with students. We actually do a pretty cool demonstration with a regular penny. We take that penny and we put it in a solution, and we don't explain to students exactly what we're doing at first. We just want them to see this. So we take this penny and put it into a clear solution that actually has sodium hydroxide. It's made of sodium hydroxide. And we also have some zinc filings at the bottom, or some mossy zinc at the bottom of the beaker. And if you heat that up at a mid-range of heat and drop the penny in, you'll quickly see that the penny turns a silver color, and we can show that to students and kind of ask them, what do you think occurred? We then take the penny out with some tongs and rinse it off and place it on the hot plate, and then what we don't tell students, but what you might know if you've done this before, the zinc and the copper on the surface of the penny go into solution and turn into a really beautiful golden color. And so we ask students, with this demonstration, did we just turn copper into gold? And that begins an entire 6-week exploration of whether it's even possible for us to turn copper into gold. Is it possible to change one element into another, and can that be done in the classroom? So students are given an opportunity to explore the atomic theory that they would need to learn to determine that. And so we include in this section, we include nuclear chemistry along with the traditional atomic theory, so students can get a full picture of that. We move on from that unit into Unit 2, Smells, and in this particular unit we're asking the overarching question, how does the nose know? Why is it that we are detecting certain compounds and not others with our nose? Like, why do some compounds have a smell and others, why do others not have a smell? And we're doing this to get students to take a closer look at covalent bonding, and molecular structure and properties. For our third unit, we actually tried to tie the chemistry content that's being taught to what's going on in our atmosphere. So we're asking students, how is chemistry related to the weather? Today's workshop will be a lesson from this unit, and so students in this particular unit are looking at phase changes and the behavior of gases. And our lesson today will be on Boyle's law. So I won't talk too much about that. We'll get into the lesson shortly. Our fourth unit is our toxins unit, and in this particular unit we are asking students to think about amount. How much is too much? When does a substance become toxic in terms of amount? So students are looking at mass amounts and molar amounts and doing stoichiometry. We're also getting a chance to teach about solutions chemistry and acids and bases. Our fifth unit is our thermodynamics unit, where we explore the nature of fire. And finally, Unit 6, Showtime, students are actually during this unit creating a chemistry demonstration to illustrate reversible reactions and chemical equilibrium principles. So this is the full year of inquiry-based chemistry that students will be learning all year. And just to be clear, the student book contains all of the lessons for all the units, but you as the teacher would get 6 separate teacher guides. And part of the reason for that is simply that there's just so much information that we're giving to you that we couldn't put that in a wraparound edition. It wouldn't fit in the margins. So let's actually jump into maybe I'll take a second. Does anyone have any questions that need to be answered right now about the
There have not been any questions entered. So again, just a reminder to anyone, if you have any questions during the webinar, the question panel on the right-hand side of your screen, you simply type them in and hit submit, and I will either read them out loud for Jeffrey to see, or I will answer them if I can. But again, I'm math.
And I'll be asking you to give some responses that you think
Yes.
your students might give to some questions. And so this workshop, Feeling Under Pressure, Boyle's Law, I just ran this workshop with Dr. Stacy at the National Science Teachers Association meeting in San Francisco. And so for some of you that may have been at NSTA and didn't get a chance to go, we wanted to run this as our online workshop. And for those of you that did not, what we'll try to do is give you a sense of what you would experience if this were an in-person workshop. And so with the Living by Chemistry lesson, and the way that I would begin a workshop, it would be to just jump right into a lesson. And so up on the screen now, you are seeing what we call our Chem Catalyst question. This is our warm-up opener. And for those of you who are not familiar with how the lessons are run in Living by Chemistry, students know that there is no wrong answer to this question. We are just giving them a chance to think about the chemistry as class begins, and for you as the teacher to assess some prior knowledge. So what do you think your students would say to this question? If you have an empty plastic water bottle, I believe I have a picture of that, just something like this, an empty plastic water bottle with a cork fitted in the end, what do you think students would think would happen if we stepped on that bottle, and then how might they explain that in terms of pressure and volume? And to give you a sense of where students are in this unit, we've already covered some directly proportional relationships, and we've looked at, for example, Charles's law already. And we've introduced to students the concept of pressure before getting to this lesson. They've seen some good demonstrations and done some work around that. So they may or may not be comfortable with number 2's explanation, but this is a good chance for you to find out what they've taken in. So just imagine that that's where they are. And what do you think your students, go ahead and type in to the question panel what you think your students might say to this.
And I'm not seeing anything coming in. So again, your question panel is on the right-hand side. It's in your control panel. If your control panel has minimized, you're going to look for a little arrow up at the right-hand side of your screen, and that will maximize your control panel. But there we go. Oh,
Right,
we got the cork's going to blow out of the bottle from Diane.
So Diane says that, and I'm sure students would say that. Andrea says that her students might say the bottle will be squished and the cork will blow out. Another comment is the cork will pop off the bottle. How far it shoots depends on how hard you step on the bottle. It'll pop out. So these are comments that students might say about this. What might they say about the pressure and the volume of that system? Okay, so the bottle is squeezed. What might that mean about the volume of the system? And whether students are able to answer this or not at this point is not actually what you're trying to figure out. Someone is saying that, oh, their students might say the volume is smaller, the volume is decreasing, and so the pressure is increasing. Students may or may not have an idea about that at this point, and you're getting a chance to assess the room and find out, well, what do they know and what do they think about this? So let's actually take a look.
So the harder you push, the skinnier it gets. I like that. I wish that were true in real life.
Let's do this. I actually recommend that if you run this lesson to just go ahead and try it, right? And we tried to slow this down, but this particular camera doesn't have enough frames. But as you can see, we did smash on the bottle, and the cork has popped out. It's not the greatest video ever. My technology is a little
Was that
weak there,
Andre's foot? It looked like
that was Andres, one of our colleagues here at KeyPress. You'll see a picture of him later because he helped us to demonstrate some other lessons. So at this Chem Catalyst, you might show students to do this and have them look at this. And what's nice here is that you know, when we hold up a bottle like this for students, there are some students in the room that they're going to say that that bottle is completely empty, and they're not necessarily going to think that there's something in that bottle that could cause that cork to fly out. So we're getting at that level of conceptual understanding of, you know, there are actually gases in this bottle. Other students who may know that already might be able to be thinking about it in terms of the volume changing and the pressure increasing, etc. But here we've actually just, by doing that demonstration, we've given everybody a common experience to think about as we progress with the lesson. And so what we would do now is we would move quickly. Like this whole Chem Catalyst and discussion would be just a few minutes at the beginning of class, and we would let me jump back in. We would move into today's lesson, which is a lab, and we're going to be actually collecting some data, some quantitative data in terms of pressure and volume of gases. And in doing so, we want to let students know in advance that because we've been talking to them about the variables that describe gas behavior, that today the number of molecules in our system is going to remain the same. The pressure will be varying, the volume will be varying, and the temperature essentially will remain the same. And we're particular about the way that we talk about that. We do use the word constant after students have gotten more familiar with this idea, but sometimes when we say that word, that, you know, that the temperature is constant, it can be confusing for students, like for when we talk about, say, for example, the proportionality constant of a particular gas system. That particular constant will be different for a different set of gases. So these terms can sometimes be confusing, and so we try to use words like it's going to stay the same or it's going to change to try to be really clear with students about what we mean. So what we're going to be using today for materials is in part one, we hand out to students in pairs. We give them a plastic syringe that you can get at a chemistry supply store online, or I actually got these from a farm supply company, and so they're very inexpensive. And if you can see, the end of it has kind of a strange looking tip. That tip is actually a screw cap that you can put a little lure lock cap on. But for the beginning of class, we're just going to hand out these syringes to students, and if those of you that have the worksheet will know that we're asking students some questions about that. And we asked Andres there on the right and Afia on the left to kind of show what students will be doing at this point. And students will be just covering the end of that syringe with a finger and trying to change the volume and describing what they might experience.
I like the safety goggles.
And well, we're emphasizing safety in this lab, even though this particular part of the lab, there's very minimal safety involved. We want to get students for the next part when we do seal it off to be ready to have those goggles on. So what might students say about here? What might they be experiencing here as they press in the plunger? What might they say to you that they experience? And go ahead and let us know in the question panel what you think your students might say. So there's a difficulty in pressing the plunger, is what one person is saying, and is, you know, is it difficult at first? Does it become difficult as you're doing it?
Oh,
easy at first, but then it gets more difficult, as Diana is saying. They feel something pushing out on their finger. It gets harder to push. The air is pushing out on the finger. Yeah, these are experiences that we want students to have, and this helps, for example, if that demonstration in the beginning, it helps for those students who might think that, oh, well, this is empty, there's nothing in this container. So now they're getting some evidence that there's something in this container, and it's getting harder to push, and I'm feeling something on the tip of my finger. And they might even, you know, if they move their finger, hear some of that gas escape, so there'll be some, you know, like hiss noises that they might hear, and can talk about in terms of qualitative observations of what's happening when we change the volume in this system. And so we have students do this qualitative experience and they're writing down what they might observe or notice on the worksheet, and then we want to move and explain to them that for part 2 we're actually going to make this into a quantitative experiment. And you can see on the right I've got the little syringe and lure lock cap. We'll bring the volume out to 50 milliliters, and then we'll cap it off. And this is where we really want to make sure students understand that you don't want to be pointing this in anyone's face, and if you do press down too hard when you're using this, the tip can break or the syringe could burst. I have not actually seen that happen, but I've seen tips break. So we want to just make sure students are wearing goggles and are paying attention to safety. And what they're going to be doing, as you can see in this picture, is holding the syringe perpendicular to the regular bathroom scale, and they're going to be depressing that syringe in regular intervals to change the volume, and they're going to be recording the weight in pounds that registers on this scale. And so we asked Josephine, who also is here at Key, to work with Andres and Afia, because with this particular activity, it would work best with groups of 4, but it can be done with 3. And the reason why is, as you can see, Andres is going to be the one that's managing the syringe, and he needs to, to kind of focus on that. Afia will be reading the volume and reading the measurements on the scale, and then Josephine's going to be recording that. And so as you can see, we start off, and there's a data chart that you should see where we're starting off at 50 milliliters, and the weight that we've applied so far is 0. As we press down and we move it down to 45 milliliters, they recorded a weight of 7 pounds. And I'll jump through this quickly. Their next reading was 35 milliliters in the syringe and 10 pounds on the scale. We went down to 30 milliliters, and now we have 18 pounds. 25 milliliters was a 24-pound reading. 20 milliliters, and it is getting a lot more difficult here. If we had this on video, you could see the struggle that begins at about 25 to 20. And so 20, it was about 30 pounds, and then we actually got it down to 15 before the tip snapped, and that was about 40 pounds registered on this scale. And as you can see, this is just a regular bathroom scale, not a digital scale. We want the dial scales, the digital ones. I've tried it with those, and it kind of recalibrates in between, and you don't get good readings. So this is an inexpensive tool that you can pick up at Target. If you have enough for your class to work in groups of 4, that's great. Or you could modify it to do it sort of what we're doing now as a demonstration for the class. But as you can see, we've got some changing volumes, and we can talk to students about that. What's happening as the volume is decreasing, and what's happening to the weight. And how are we going to translate that into pressure? So what I've got for you, and this is using one of Key's software programs called Fathom. And what you'll see, and for those of you that have the worksheet, we provide a data table for students, and on that data table we have them recording their volume and the weight that they are seeing, that they're applying to this system. And because students have learned about pressure, this is a chance where you could take advantage and differentiate. If you want to push some of your more advanced students, have them determine, what force per unit area are we talking about here? And for students that might need a little help, we're actually talking about when you're pressing down on that syringe, the cross-sectional area of that plunger that's being pressed down, that circular plunger. And so if students were to take the weight applied and divide it by their area, they would have a pressure measurement. However, and here's another, and that's what this is here, that their applied pressure is their weight divided by their cross-sectional area. However, that's not the only pressure that's affecting the system. We have to take into account the atmospheric pressure that's pressing down. So all of our applied pressure values we add 14.7 pounds per square inch to account for the atmospheric pressure. And again, that's a place where you might have more advanced classes thinking about that and working on their own, or you might be scaffolding for classes that need that scaffold. And so what they'll have in the end is a total pressure of this, a rough figure of the total pressure of the system in the syringe versus its volume. And students might get a graph that would look something like this. And as you can see, with our this is our dynamic software called Fathom that KeyPress sells, and you do not need to use Fathom to do all the lessons in living biochemistry, but this particular software can be used with any science class, and it's a good tool for looking at data that's collected, and especially to have students work with it on their own. So students may have seen this and tried to fit a best fit curve on their own here. But also students might not be sure what's going on here, and I'll go back into the well, we'll thank Andres and Sofia first. Thank you, Andres, Sofia, and Josephine for collecting our data. And if we jump back in, this is just to give you a sense of what students have been exploring so far in the unit. We have been introducing students to directly proportional relationships prior to this lesson. So for example, we did a lesson where students looked at the changing height in a rain gauge of the height of the liquid that's being collected. And it turns out that there's actually a proportional relationship if this is a regularly shaped container with parallel sides here. So as the height is increasing, the volume is also increasing, and we can write that relationship as we do over here. Volume is equal to some constant times the height, and you can see that that constant is the slope of this line of our volume versus height. So students have looked at that, and we've talked to them about what we mean by a direct proportion, and if we had data that was related directly, that we could plot that data and see a linear relationship that goes to the origin. So students are familiar with this. We also have them revisit the concept of density in this unit. We first introduced it in Unit 1, and here's where we're showing students, where do we come up with this density equals mass over volume formula in the first place. And so we're having students look at, with water, the mass versus the volume, plotting that out for liquid water, frozen water, and we provide them with some information on mass and volume of snow. But again, they're seeing a proportional relationship, and in this case, the proportionality constant is the density. And so they can kind of see where this formula comes from, that it's not just something that you as the teacher write on the board because you're the teacher or because it's in the book and that students have to memorize it. They can see where these formulas are coming from. And so, as I said also, prior to the pressure lessons, we have students looking at volume and temperature relationships. And so here we can show students that that when the number of moles and the pressure is held constant or doesn't change, that the volume varies with temperature in a directly proportional way as well. So our volume is related to that temperature by the constant, which is the slope of this line, and we can get a formula that might look familiar to some students where we can talk about, well, if we had initial conditions, say we were looking at temperature being 100 and the volume being 200, for example, on this blue line, if we were to change the temperature to something that was higher, they can kind of look at this graph and see, oh, I can see now why there would be another volume related to this particular system, and how they might solve for that. So they might solve for the proportionality constant and set it equal to their new conditions, or they might actually come up with this initial volume over temperature is equal to final volume over temperature. So students have worked with these relationships, and let's go back, and now they're seeing data that they've collected that doesn't quite look the same as those previous relationships. And so what can we do to help students to understand what's going on here? And what I would recommend is that you might have some ideal data for students to look at, because the data that they collect in class, especially with the syringe and scale, will be there'll be deviations from the the ideal relationship. And so what I have here are some volume and pressure data that is ideal, and what we might actually have students take a look at is, and I'll show you with Fathom how easy it is to do a graph. We might grab the pressure and see what that looks like versus the volume. And here again, students are seeing something similar to what they collected in class. Something else we might ask students to do here is, with those other relationships, they were seeing that if you took one of the variables and divided it by the other, it turned out to be a constant value. So maybe we could take the pressure and divide it by the volume and see what that looks like. And if I did that here, Fathom is nice where you can do some of this analysis. Let's take a look at pressure divided by volume. And I'm gonna put these all at one significant digit just so that relationships are easier to see. And as students are looking at the results here, they're not going to see that it's the same value, that this number is varying as the pressure and volume changes. So maybe we would have them look at pressure times volume, and if they were to do that, take a look at pressure, multiply it times the volume, And you can see here that if we're getting something that's a little bit more significant here, and I'm going to round this to one significant digit. And if we were to do that, students, interestingly enough, would notice, wow, every time I've multiplied the pressure and the volume, I'm getting the same value. And that in itself is interesting, and we can talk about that as it relates to the other directly proportional relationships that we've already learned about. And something else we might have students do is take a look at the inverse of the volume. And what we would do here is we'd have students take 1 and divide it by all their volume values. And again, I'm going to just format that. And here's something that we can have students look at now that we have, this is our 1 over V, right? And so what if we were to graph pressure versus 1 over the volume? And here is something that might be very interesting to students, is that they're going to be looking at something that looks familiar to them now based on the directly proportional relationships that they looked at. If students were to estimate, we can with Fathom add a movable line here, and we want that actually to go through the origin. Now students can kind of try to find the best fit for what is clearly a linear relationship. And one of the things we can do with Fathom that's nice is we can actually try to get the best fit by looking at a least square regression. So all these points are a certain distance away from this line, and if we were to use that distance and square it and add those values, if we can get the sum of those squares to be the smallest possible, we're going to have our best fit line. And as you can see, and it might be a little small, what's happening down here below is you can see the pressure is equal to some number that changes as I change the slope times that inverse volume, or pressure is equal to some constant times 1 over V. And so that, as you'll see, the best fit happens to be when this K value, this slope value is 5, just like our pressure times the volume values happen to be. And we can show students that that's why we can plot a function here where there's some constant divided by that volume. So now our formula, pressure is equal to some constant over volume, is going to give us that curve that we were seeing in our data before. And you can see here that if this K value represents the slope over here, or the K value here. If I'm changing this, we get a best fit as I approach that value of 5. And so, as I said, this program is not required for doing the Living by Chemistry lessons, but you can see that Fathom can help with this kind of analysis of data. But what's important for students here, and I'm going to jump back into it, is to be able to look at their own data that they collected and see how it's similar to and different to the proportional relationships that they've been examining so far. So let's jump back into the slideshow. So again, students have looked at directly proportional relationships and have been able to determine initial and final conditions because of this directly proportional relationship. Now we're going to introduce the students that what they've looked at today, when one of these variables was decreasing, the volume was decreasing, our pressure in the system was increasing. And we've shown them that this is inversely proportional, and part of how we've shown them that is by taking the inverse of that volume and seeing that directly proportional relationship. And now they have a better sense of where this particular formula for Boyle's law comes from and why it's possible to set our initial pressure and volume conditions equal to a final set of conditions and solve for an unknown. And so this is just a little bit different than how it might be taught in a traditional course. In a traditional course, one might put the definition for Boyle's law on the board and show this mathematical relationship and perhaps show some data with a graph that has this curve that shows an inverse relationship and possibly show some, multiplying some pressure and volume values to make sure that students see that that's constant, and then maybe some example problems. And a lot of times this encourages students to just memorize the formula at the end, P1V1 equals P2V2. And we want to emphasize to students, where are we getting these formulas, and we want them to have an experience that helps them to understand what's going on so that they can explain this beyond just plugging numbers into a formula to get an answer. So we would get to the end of class, and we would ask students a check-in question. And our check-in question today is, if you have a balloon that's filled with gas and it occupies 7.5 liters, and the pressure on the outside of the balloon is 1 atmosphere, what do you think is going to happen to the pressure inside the balloon if it's placed underwater at a depth where the new volume has changed to 2.5 liters? What's going to happen to the pressure? And we're assuming, of course, that no gas is going to leak out and the temperature is going to remain the same. What might students be able to say to this? Like, is our pressure going to increase or decrease? Go ahead
And
and
I was going to say they need to be answered. Oh, there we go. Increase from
there we
students.
go. So students saying increase, increase, and you know, if we go back here, we can actually have students determine by how much will that increase. And this is a chance for you to find out, did students get the main idea of this lesson? Do they understand these relationships? And can they now begin to work on some problems where they would be solving for this final pressure? And I do see a question that says, do you find students wanting to say it's an indirect relationship? And I haven't heard students say that, but I wonder if, have you heard of that? I mean, you taught mathematics. Karen, have you heard that when you taught math, direct versus
Well,
inverse
because in
proportion?
mathematics we actually do say direct variation. So yes, it
But
does.
but does indirect relationship come up? That was the question. Because I don't know if
I don't honestly. For me, I haven't ever noticed it, but that's probably because we steer them to the inverse vocabulary, right?
so. Yeah, so that's what I've noticed too. And with this particular lesson, we are kind of guiding students to that language. So and it's kind of another advantage of a guided inquiry lesson where students might be talking about it in their own words, and we might guide them by giving them, well, this is how we would say it in a science class or in a mathematics sense. So here we are at the end of the lesson. We can see that that students should be able to qualitatively describe whether there'll be an increase or a decrease here. Students should also be able to, if they use their formulas, determine an actual value, and we would then send them off to do their homework. And so before I jump into the homework here, I have another poll question, and some of you that have been on these webinars have answered these before, so bear with us. But I'd like to know, in your own classroom, your own chemistry class right now, how often do you assign reading and practice in your current textbook that you are using? Do you give these assignments every day? Do you do it once a week? You know, roughly, you know, maybe a couple times a month, or maybe you're not using your book at all. And I very rarely used my textbook when I taught chemistry in the Bay Area. I used it when I was absent and had it a substitute. So I'm going to close this poll and share that with you. And we're seeing that many of you are doing maybe once a week, having students work with their textbook. Some of you a few times a month. No one is using it every day, but also some are saying that, you know, I have been in workshops before where I've heard teachers say, I never use the textbook. And for those of you that are only using it once a week, why might you not be using that textbook each day?
And Jeffrey, we have someone, Paul, said that he uses the textbook supplemented by online homework.
Okay.
That's interesting.
That is interesting. And there is, we'll see later, there is an online textbook for Living by Chemistry, and there are ways when you're using sci-links to go to additional exercises. What I've asked teachers before is, why are you not using your textbook? And it says, well, here's somebody saying that they need to practice reading scientific material, and we agree, like that students should be reading science as well as practicing it in class. But often what we hear from teachers is that the textbooks that we're providing for the students can be very difficult for them to navigate, that it might not be accessible to all the students in the class, or that students, for example, had a great lesson with you in class that day, and then they go and read about the theory in the textbook, and it doesn't quite match up with how it was taught that day in class. So there might be some kind of disconnect there. And so what I found that I was doing a lot of when I was teaching chemistry was I was giving a lot of notes for students and giving them assignments in addition to their textbook, or having to decode their textbook for them. So what I what I would ask you now is if you do give students notes, um, how often do you think they actually look at their notes? Do they look at them a little bit each day if you're giving a few notes each day? Are they kind of cramming it in before the quiz or test, or are they not looking at their notes at all? And I'm going to close this now because just about everybody is saying that students tend to just look at it the night before. And I asked those two poll questions, and I bring that up simply because I want to show you that this textbook for Living by Chemistry that goes along with all the lessons that are outlined in the teacher guides addresses a lot of the issues that come up with using a chemistry textbook in class. And so, for example, if we were to assign students pages 299 to 303, I've actually got an excerpt of that, you would see that after today's lesson, students would have a short reading. You can see it's 1, 2, 3.
You need to hide your poll, Jeffrey.
Thank you.
Not that we don't enjoy looking at the results.
But it's more fun to look at the student book.
It's a little more fun to
Back
look at
up.
the book.
So here's what students are getting in the evening, and I'll show it quickly. It's 1, 2, 3 pages and a little bit plus, and some practice problems that are based exactly on what they learned in class today. And just to kind of point that out, for example, we have students open up their reading with some pre-reading, think about it questions, and an outline of what they're going to cover. You can see here that students then move on to explore the topic as they read it, and here they're seeing an image of what they just did in class. Here's that qualitative experiment where they're putting the end of their finger on the syringe and changing the volume. We then remind students about the lesson they did with the syringe and scale and some data that could be collected. We talk about how we analyze that data in class. So all of this is a chance for students to review what they did in class, to reflect on the concepts, and then you can see here that we're formalizing Boyle's Law at the end of the lesson, just as we did in the classroom. Instead of starting off by telling them what Boyle's Law is, we want students to kind of come to that through their experience. And we sum it up and give students a chance to practice. And so what students can do every single day, they're going to have a guided inquiry-based lesson every day on these chemistry topics that will cover your full year of standards, and then they're going to have a reading that ties in directly to their classroom experience. And as you saw by the imagery, that this is a very accessible textbook. We're using lots of visuals when we can. We're trying to reach more students and help more students to learn chemistry. And if students are doing hands-on guided inquiry-based lessons and then reading a little bit of chemistry each day, you're going to see a shift in their performance in the class. And we're hearing from, for example, from school districts like Boston who use Living by Chemistry for all their public school students, that students are doing better when they enter into AP chemistry or when they go on to take college chemistry. So our student textbook is, we're happy to send you a sample of that if you want to. You can see how you can download a sample of it toward the end. I want to actually, before I do that, just debrief quickly. All the lessons in Living by Chemistry follow a particular lesson design, and for those of you that are familiar with it, it's a modified version of the 5 E's. So students begin each day with what we call the engage section of class, where they look at that chem catalyst question and give some answer that gives you a chance to assess what are they coming in with, what do they know as they enter class, and what misconceptions might they have that you're going to have to address as the class progresses and as the topics progress. Then there is, after the chem catalyst, there's always some type of exploration where students are exploring the chemistry content before we tell them about it and before you maybe give them formalized definitions or notes. And so this explore section, for example, today was that laboratory where they did a qualitative and a quantitative exploration of pressure and volume relationships in closed systems. But that lesson, for those of you that were in our previous webinar, we did a smells lab as a part of that exploration. But we also have demonstrations that you might be doing, and students would be observing that. There are different activities that use hands-on manipulatives that we provide for you in kits. Sometimes it's just a classwork where we've provided students with some data to look at, and maybe we've put some gaps in that data and ask students to make predictions, and it could be a computer simulation. Among the many types of lessons in Living by Chemistry, we want to make it clear that it's not that you have to have a full-blown lab every day. to teach guided inquiry, but what we want to do is give priority to evidence for students. We want students to be looking at data that has been collected or collecting their own data and looking for patterns as they go through each class. After students have done that, have collected and looked for the patterns in the data, that's the chance for you as the teacher to begin a discussion where students are explaining what they learned, and you're maybe asking them to go further and elaborate on that. And here's where you might be presenting them with, as we did today, a formal definition of what is an inverse relationship versus a directly proportional relationship, and that this pressure-volume relationship is called Boyle's law, and here are some example problems that can make use of this relationship. And so this is happening after students have explored. And then at the end, we're checking in. So every lesson, there's a chance for you to assess student understanding. And different teachers manage these lessons in their own way. When I taught with Living by Chemistry, I would have students record their chem catalysts and check-in questions, and I'd collect them to give participation points. Some teachers have students recording this in lab notebooks. All the information that's in your teacher guides, we want you to know that that's a suggestion for you, and we hope that teachers will take what they need and modify to their own classroom needs. And so let's see, we've got a little bit of time. I will just quickly, so that people have a chance to kind of think about what's covered in the Unit 3 weather. Very briefly, we've broken this unit up into 3 main sections. And so in our first section, we're looking at volume, phase changes, and temperature. And when we started there, because students are often more familiar with measurements of temperature and volume than they are with pressure. So, and we also wanted to introduce the directly proportional relationships before moving on to the inversely proportional relationships, which we do in section 2, where we talk about pressure, and then we end this unit talking to students about number of moles, so that we can build toward the ideal gas law. And so, you'll see, for example, that we're relating this to everyday occurrences in the weather, for example, high and low pressure systems and precipitation, etc. And we're doing that throughout the unit. We're having students look at proportional relationships, and as we talked about, for example, with a rain gauge, volume versus height, looking at mass versus volume of a particular substance like water to see how density changes with temperature. We have students actually in this unit building their own thermometers and looking at temperature scales. And I'll point out with that we actually do not introduce temperature scales to students until Unit 3. Unlike what might be in a traditional textbook, we don't have a first section that is all the measurements and significant figures and scientific notation and all of that mathematics at the beginning that's somewhat out of context for students. I used to think of that as kind of a frightening first unit for students, where we're kind of hitting them with all this math in the beginning out of context and then having to reteach it again, for example, when we really want to look at temperature scales. And so what we do is, with these mathematical concepts, is we're introducing them at the point of use. And we have a math spotlight section in the back of the book for students if they need a comprehensive review of the math topics. So section 2, as I said, is the section where we're introducing concepts of pressure. And so we're looking at gas density, we're looking at air pressure, pressure versus volume, Boyle's law. These concepts are all covered in section 2. And in our final section, we're looking at number density, or N over V for students. And we're looking at, of course, Avogadro's law and the concept of the mole. And we're moving students toward the ideal gas law. And so we're hoping at the end of the unit that students are making good connections and can give good explanations about phase changes, volume, density, temperature, pressure, and the number of moles, and can solve problems, using the ideal gas law and any of these gas law relationships. And so this would be the end of the unit, and I'll briefly take you through kind of a tour of what do you get as the teacher if you were to move into a curriculum to start using Living by Chemistry. How, what support do you get to teach lessons in this fashion each day? And just so that you can see, if you go to our website, keypress.com/chemistry, and I'm going to see if I can open that up for you. Let me just quickly go there. If you do keypress.com/chemistry, that will take you to the Living by Chemistry page at KeyPress. And I want you to see that. Hopefully it'll happen quickly.
What are we doing here?
I want to just show here it is.
Oh, there it is. Yeah.
This is the Living by Chemistry webpage at KeyPress, and here you can actually download more samples of our materials if you haven't already. So for example, we've included 8 lessons from Unit 1 Alchemy, so you'll have teacher guide samples of those lessons and the student edition that goes along with it. We also have a little brief example of the teacher resources that go along with it, and in addition there are some other activities that you can download and use in your classroom, and we're hoping that you'll try them out to see how they work for you and your students. So that's at keypress.com/chemistry, and let me jump back in here. If you were to do that in that sampler, you will find, as I said, an excerpt from the Unit 1 Alchemy Teacher Guide, which has more information than any wraparound edition, and gives you all from start to finish, from setup, safety, the chem catalyst, all the way through the check-in and safe disposal of any reagents. That's all included for you in the teacher guides. The student textbook, you'll get an excerpt of that, and that, as we've talked about, goes along with the daily lessons that are happening in class. So what you teach in class, students will be reading about that night for homework. We've included in that sample that you download online the excerpt from the solutions manual for the questions that we ask students in the student textbook for that section in Unit 1 Alchemy. We've included an example of our assessments, which include quizzes for each section and exams for each unit and lab practical exams for the first 5 units. Our 6th unit, we have students doing that demonstration that I mentioned, so that's the lab practical for Unit 6. And we're asking students questions in multiple formats, and we're really pushing students to give explanations for their reasoning and evidence to back up what it is that they're talking about and giving as a response. If you had a chance to download the worksheet that students would be using with today's lesson, that actually comes from our Teaching and Classroom Masters ancillary. This ancillary also has other handouts that might have imagery or diagrams or charts that you might want to show during that explain and elaborate portion of class where we're formalizing ideas for students. Those are also available for download as PowerPoint presentations, which I'll show you in a minute. As I mentioned, there are some lessons with Living by Chemistry that make use of what we call the Living by Chemistry kit items, and these are card decks or molecular modeling kits, the weather map transparencies. These are tools that are tied to certain lessons with Living by Chemistry. Again, we want to give students some opportunity to look at evidence. So for example, they might be looking at the created table cards that have all kinds of evidence about the elements, the atomic mass or the number of valence electrons, that kind of thing. And we want to give students something that they can work with and talk about and look for patterns. So these are the Living by Chemistry kit items that would come along with your adoption of Living by Chemistry. All the resources that you would see in print for you as the teacher can be downloaded from our online resources at Key Online, and you'll also see that we have a forum for teachers to talk to each other about how they're modifying those lessons for their own purpose, and to give tips and suggestions. And you'll see here any updates if we add things to Living by Chemistry. And as I mentioned, students will have access, you'll give them a class pass for an online textbook that has all the material from the regular textbook with a few features, that you can click on a key term and go to the glossary, that kind of thing. So that's for students if they have access to an online environment at home or at school. And we'll kind of end and give you a chance to give us some questions if you have any by letting you know if you're coming up on an adoption for a new chemistry program, why should you choose Living by Chemistry? And for one, this is a research-based program. We've had lessons out in the field. Our preliminary edition was out for 5 years where we got teacher feedback and student feedback, and we are seeing that we're getting good results and that students are succeeding in chemistry. More students are succeeding in chemistry with Living by Chemistry. The guided inquiry, as well as the student textbook that's tied to each lesson, is giving students more access to the chemistry and more practice. These lessons, you'll see, have differentiation built in so that you don't have to to do extra work to have differentiation for a class that has different levels of ability, and all the materials that you need for support are provided for you. So that would end our introduction to Living by Chemistry and our Unit 3 weather. I want to thank you for attending, and I want to give people a chance to ask questions that they might have.
And I've got a couple questions. One, I think you pretty much answered, but I just want to verify. They asked about the assessment resources, if they were included in the teacher units or if they're separate. So my understanding is they are a separate ancillary, correct?
Assessment resources is a separate ancillary, and it's available on paper. You would have the book itself. You would also have PDF versions on the online resources, and we've also made all of the assessments as Microsoft Word documents so that you can modify them if you need to.
Okay, and then there's a question about the kits. How many students does a kit work for? If, for example, this is from Mark, they have 4 sections, so do they need 4 kits? Or is it something?
A teacher would just need 1 classroom set of kits, so, and it's all reusable. So if you have 5 classes of chemistry, and you're the one teacher that teaches chemistry, you just need 1 set of the kits. And the kit items are divided up depending on the lesson. For example, it might be a group of 4 recommended lessons. So if we had a card deck, that you would have 8 card decks for a classroom size of approximately 32. So it's a classroom set that you can use, and you can even actually share that with another teacher if you don't both teach a Living by Chemistry lesson at the same time.
There is a question about someone who's actually adopting in the fall. Yay, Sharon. They want to know if there's many people who are currently using it with a block schedule, which would, I assume, be the 90-minute type of thing.
I definitely have talked to teachers that are using Living by Chemistry on block schedule, and if you want, Sharon, you and I can email or talk in more detail about that. But what a lot of teachers are telling me that they do is they're combining lessons, because these are all lessons that are designed to be about 45 minutes, and in that combination they might make a decision, for example, to not run the lessons back to back, but to perhaps do the Chem Catalyst for the first lesson, run the exploration of the first part, and then maybe move into the second lesson and doing a check-in at the end for both. There are different ways that teachers work to make that 90-minute period be the most effective, but we definitely have teachers doing that.
Okay, and there's a question about the standards that are being taught. Are they very clear in the textbook? This is Andrea, who's from California, which, as we know, is very standards-based.
Yes, many states are very standards-based, and so what we do is we post correlations on the Key Press website and on your state resources. So you can download a document. I don't think we have done our California correlation yet, but it's something that we can do when we get that request, and we'll let you know, like, these are the standards that your state say you need to cover for chemistry, and these are the lessons that Living by Chemistry uses to cover them. Any other questions?
I don't see any other questions, so if anyone has a question, now would be the time to type it in. If not, we're going to end 5 minutes we got left, so we're happy to stay on as long as you have questions, but if not, we will say good evening to everyone. Doesn't look like I'm seeing any questions coming in, Jeffrey.
I think everybody has had their questions answered. We want to thank you for joining us today to learn about Living by Chemistry, and to let you know that we will be doing these Living by Chemistry webinars on a monthly basis. If you check back at the end of the day, Friday, I'll have my topic up for April. So I haven't chosen that topic yet. If you have any suggested topics you would like us to cover, and how do we cover that topic in Living by Chemistry, feel free to send me an email. At the end, I believe, Karen, when you close out the webinar, there'll be a survey.
There's a quick survey, and there is a place to actually put in a free response about what you'd like to see. I see a question real quick from Diane about the certificate of attendance, and yes, thank you very much for attending. You will receive in an email from me a certificate of attendance. It usually takes me about a day to get it, so you should get it by tomorrow. And it's just good. It's just a certificate that says you attended a 1-hour PD on Living by Chemistry. So if your district allows you to use that for continuing education credits or professional development, you will receive that hopefully by tomorrow.
And I see Paul Thompson mentioning as
it's actually Mark.
Well, is it Mark?
Mark is sitting in for Paul. He told me that earlier.
Mark's sitting in for Paul, which I wouldn't know. Is asking if I'm going to be out in New York next week, and yes, I am. I'm going to be there on Friday, I believe, to do some work. I forget the school name. I apologize. But I'm also going to be at the Science Council of New York meeting and doing 2 workshops there as well. But I'm doing some workshops, I believe, wherever it is that Paul is
Paul or Mark?
HSMSE. I believe that's the school that I'll be at, and
Oh,
so
great.
yes,
High
yes,
school
that's where I'm going to be next Friday.
Oh,
High
great.
school
Well, then you
math.
guys will get to meet Jeffrey. That's exciting.
It'll be fun. We're going to do actually some acid bases lessons.
Cool. All right. I
That's from
don't see
Unit 4
any other
toxins.
questions. And and I will do that, Andrea. Andrea has asked me to spell her name correctly. I will. All right. So thank you so much for joining us. Thank you, Jeffrey. This was great. And again, if anyone has any questions after we end the webinar, feel free to email Jeffrey or myself, and we will make sure they get answered. And your certificate should come sometime tomorrow. And the recording of this webinar will be up probably by tomorrow, but maybe not till Monday. But it will be up for view on demand. So thank you again, everyone, for joining us. Thank you, Jeffrey, and have a lovely evening.